Hello students, welcome back. I am teaching a course on circuits and system, and we are discussing the Fourier series. In the last class, we have seen how a Fourier series is represented. So if I write it back, you know that a Fourier series was written as f of t is equal to a0 plus summation of I is equal to 1 to n of an cos n omega t plus bn into sine of n omega t. So with this equation in mind, a more compact representation of this series, either in the signage or purely in the cosine forms, may be obtained. So we can obtain a new and compact representation, which may be either purely that of the sine waves or purely it may contain the cosine components. Let us see how. For this, you remember that the first harmonic of a pulse. So this period t or f is equal to 1 by t. So this is known as your fundamental frequency. Now, when a signal is transmitted, or for that matter, any signal may compose of number of other frequencies as well. So those frequencies are called as the harmonics. For example, if I write as a frequency of 1f, so this is known as a fundamental frequency. Fundamental frequency. If I multiply this by 2, that means in the same time period, if there are two pulses, two waves, that means equally we can say a signal of double this frequency. Then how that could be represented? So you can represent that signal as having two pulses. Let me draw here itself, 1, 2, and completing 2. So this frequency is, this signal is of twice the fundamental frequency. Similarly, so this is known as a second harmonic. So if the frequency is 2f, this is known as a second harmonic. So if this frequency is 3 times the fundamental frequency, that will be third harmonic, fourth harmonic, fifth, and so on. So in general, we can say that this signal is composed of the n harmonics. And for that nth harmonic to be represented, we can write f of nt is equal to an into cos of n omega t plus bn into sine of n omega t. Now, if you take two vectors, for example, let me take the two vectors as, let's say this is vector A or an, and another vector, let's say bn. So I can say, I can now form another vector which is called as a cn. And if you find out this value of cn at this particular place, for example, I know what this cn will be equal to. The cn will be equal to square root of an square plus bn square. Now, if you multiply this signal by cn, so if you write this as equal to cn by cn and write it as an cos of n omega t plus bn sine of n omega t, I think there is no change in the signal. If you write the value of cn as equal to square root of, square root of an square plus bn square, and you take this cn down this side, so I can write an into cos of n omega t divided by square root of an square plus bn square. Similarly, plus I can write bn upon this value here as square root of an square plus bn square into sine of n omega t. So this is what exactly the f of nt is equal to. Now with this one, I know what this an upon, let me change the color and write it. I know what this an divided by an square plus bn square root, or bn divided by square root of an square plus bn. From this I know that the first term is nothing but equal to cos of theta. If I say this is my theta, along this axis this will be cos of theta, along the vertical axis it will be sine of theta. So therefore writing for this as cos of theta, and for this if you write sine of n theta and putting this value back in these places, so my equation will turn out to be square root of an square plus bn square into cos of theta n into cos of n omega t plus sine of theta n, that is this term, dot sine of n omega t, and this all. Now what do you know here? Cos A cos B plus sine A sine B. So this term you know by the basic trigonometric formula is nothing but cos of n omega t minus theta n. So for this complete term, I can put it as this equal to this term. So therefore, this answer will become as because I know what this value is. This value is nothing but Cn. This value is nothing but Cn. So therefore, putting this value back, I will get the value Cn into cos of n omega t minus theta of n. I hope this is very clear, where I know what this Cn is equal to. This Cn is equal to this. I know given these two vectors, I can find out what theta n is equal to. So from these two, where I know what this Cn is equal to. The Cn is equal to nothing but an square plus bn square, and this theta, if you find out, therefore this theta n is equal to tan inverse of bn upon an. So from these equations, you get the values of the theta n and the c of n. Now you know that if you put the value, n is equal to 0, so you are going to get the value c0. So if you put let n is equal to 0, so there is no doubt that I'll get the value c0, and for this the value will turn out to be nothing but a of 0 square, and plus b term will become as, so if you know the second term will become as equal to 0. So therefore this is nothing but a0 itself, yani ki, or in other words what you say, the c0 is equal to a0. So therefore putting this value, therefore the Fourier series of any harmonic, therefore the Fourier series of any harmonic, whether it is the second harmonic, the third harmonic, the nth harmonic, for whichever harmonic you talk of. So therefore, for that particular harmonic, the Fourier series of any harmonic can be expressed in cosine form or in the sine form. So if you talk in the cosine form, I know this answer will be with this one. The answer, because here, because A0 is nothing but C0, I can put this value A0 as C0 in this equation, and the other equation will become as f of t is equal to C0 plus summation of I or n is equal to 1 to infinity into C of n into cos of n omega t minus theta n. Similarly, in the Fourier series in the sine form, the Fourier series Fs, Fourier series in the sinusoidal form will be equal to f of t is equal to C0 plus summation of n is equal to 1 to infinity of C of n sine of n omega t plus, let's say, some angle phi of n. So from here I can find out what the value of phi n is equal to. This is nothing but tan inverse of, because I know from this here, so I can find out tan inverse of an by pn. So you have got the equations, how to find out the compact form for any harmonic. So let me put a rectangle over there. So you get one standard formula for f of nt is equal to this, where theta of n is equal to this. This is in the cosine form. For the sinusoidal form, the equation is given here. So this is the equation. So with these two equations, then you can plot the spectrum, line spectrum for the Cn versus the n value, or theta n versus the n value. So the graph in those cases will look like one. So let me just take a pencil here. So the graph here can be drawn Cn versus n and theta n versus n. So these two spectrum will be obtained from these two equations. So therefore, this will be called as a amplitude spectrum, and this will be called as a phase spectrum. So normally in you will get numericals in your examinations, and these numericals will be one to write down what the fnt for any harmonic, whether f of 0, this will be 0, this will be 0, for f1t, f2t, f3t, and so on. So you can find out what the different harmonics for the function, and also you can plot the amplitude spectrum and the phase spectrum. These are the likely questions in your examination. We'll take up some numerical in the next class. I hope the concept is clear and you can yourself drive an equation for the harmonic, nth harmonic. So thank you for watching.